Arithmetic means of an arithmetic sequence. Our problem, we have positive 5 and then two missing terms or two arithmetic means that are missing, and then positive 50. So we need to find the arithmetic means between positive 5 and 50. First, let us identify the terms here, or the number of terms. This will be a sub 1. This is a sub 2, a sub 3, and a sub 4. Okay. So to find the missing arithmetic means, we need to use the formula a sub n is equal to a sub 1 plus n minus 1 multiplied by d. So our d here, this is the common difference. This is the common difference. Okay. So let us now find for d a sub n. So a sub n, let us use a sub 4 since we have the value for a sub 4. So this will be a sub 4 equals to a sub 1 plus n minus 1 multiplied by d. So our a sub 4 here, the value of a sub 4 is positive 50, and the value of a sub 1 is positive 5, plus our n here, since this is a sub 4, so our n will be 4 minus 1 multiplied by d. So since d is the only variable remaining here, we can solve for d. So continuing, we have 50 equals to 5 plus 4 minus 1 is 3. So this will be 3 multiplied by d. And then we have here, so to solve for d, we need to transpose positive 5 to the other side. So we need to transpose that to the other side, so that what will be left on this side will be 3d. So transposing, we will have 50. If we transpose positive to the other side, it will change its sign. So from positive, this will become negative 5 equals to positive 3d. 50 minus 5 is 45. This will be equal to 3d. So we can rearrange this. We can make this 3d equals to 45. And to solve for d, we need to cancel out 3. So to cancel out 3, divide both sides of the equation by 3. So 3 divided by 3, this will be equal to 1. We can cancel this out. This is equal to 1. And then 1 multiplied by d. This is equal to d. And 45 divided by 3 is 15. So we have the value for d. We can now solve for a sub 2 and a sub 3. Okay, so to solve for a sub 2, we will just add 15 to a sub 1. Okay, so again, using this formula, a sub 2 would be equal to a sub 1 plus, okay, n minus 1. Since this is the second term, our n here will be 2 minus 1 multiplied by 15. Okay, so a sub 2 here, or our a sub 2, this will be a sub 1. What is a sub 1? Positive 5 plus 2 minus 1 is 1 multiplied by 15, that is 15. So our a sub 2 is just a sub 1 plus 15, and this will be equal to 20. This is our a sub 2. Now to find for a sub 3, we will just add the value of a sub 2 to d. Okay. So a sub 3 here, this will just be equal to a sub 2 plus d. So what is the value of a sub 2? That is positive 15, or rather positive 20. So our a sub 2 is positive 20 plus 15. Our a sub 3 here will be equal to 20 plus 15, that is positive 35. So we can now say, or we can now write here, a sub 2 is positive 20, a sub 3 is positive 35. And these are our final answers. Arithmetic means of an arithmetic sequence. Our given problem, we have positive 7, and we have 3 missing arithmetic means. So we have here 3 missing arithmetic means, and the last term will be 63. So positive 7 here, this is our a sub 1. This will be our a sub 2, a sub 3, a sub 4, and 63 is our a sub 5. So to find the missing arithmetic means, first we need to find the formula or the value for d, or the common difference. We will use the formula a sub n. This is equal to a sub 1 plus n minus 1 multiplied by d. So using this formula, we can find for the value of d. Now, since 63 is given, okay, we will use it for our a sub n. So our a sub n here, since 63 is the 5th term, okay, so our a sub n here will be the value of a sub 5. This is 63 equals to a sub 1. Our a sub 1 is positive 7 plus our n. Okay, so since 63 is the 5th term, our n will be 5 minus 1 multiplied by d. So 63 is equal to 7 plus, okay, so we have here 7 plus 5 minus 1 is 4. 4 multiplied by d, this will give us 4d. So to find 4d, we need first to transpose positive 7 to the other side. So to transpose positive 7, we will have then 63. If we transpose positive to the other side, this will change sign. So this will become negative 7 equals to 4d. Okay, so we have here 63 minus 7. This will give us positive 56 equals to positive 4d. So we can rearrange this. So we will just put 4d on the left side, and we will put positive 56 on the right. So to find 4d, we need to cancel out 4 from 4d. So what we need to do is that we will just divide both sides of the equation by positive 4. So 4 divided by 4, we can cancel this out since this is equal to 1. So we have 1 multiplied by d, that is equal to d. So d is equal to 56 divided by 4. This will give us positive 14. So our d is positive 14. Okay, let us now find for the value of a sub 2. Our a sub 2 here will just be the sum of a sub 1 and d. Okay, so how do we do that? We will use the same formula as this one. So we have here a sub 2 plus a sub 1 plus n minus 1 multiplied by d. So our a sub 1 is positive 7. This will be positive 7 plus our n, since this is the second term, our n will be 2 minus 1 multiplied by d, which is 14. So our a sub 2 here will be 7 plus 2 minus 1 is 1 multiplied by 14, that is 14. So again, our a sub 2 is just the sum of a sub 1, which is 7, and our d, which is 14. So this will be 7 plus 14, that is 21. Okay, so we have here 21 as our a sub 2. Now, a sub 3, it's just very easy. So we will just add, okay, just add a sub 2 to, just add a sub 2 and our value for d. Okay, let's change this into color yellow. So again, a sub 3 will just be equal to a sub 2 plus d. Okay, so what is our value for a sub 2? We have 21, and our value for d is 14. So 21 plus 14, this will be equal to 35. So we have here a sub 3 is equal to 35. And for our a sub 4, okay, so we will just use the same formula. We will have here a sub 4. This will be equal to a sub 3 plus d. Okay, so our a sub 4 here, our a sub 3 is 35 plus d, which is 14. So a sub 4 here will be equal to positive 49. So our arithmetic means now are complete. We have 21, 35, and positive 49. And these are our final answers. Arithmetic means of an arithmetic sequence. Our next problem, we have positive 9 and 2 missing terms here as the arithmetic means, and positive 33. So positive 9 here is our a sub 1. Again, positive 9 is our a sub 1. This is our a sub 2, a sub 3, and a sub 4. So to find for the missing terms, first we need to find for the value of d. So the d here can be solved using this formula. A sub n is equal to a sub 1 plus n minus 1 multiplied by d. Okay, so we will use here 33 for our a sub n. So since 33 is a sub 4, okay, so this will be a sub 4. The value here is 33. Our a sub 1 is positive 9 plus our n here will be, since this is the fourth term, so our n will be 4 minus 1 multiplied by d. So we have 33 equals to 9 plus 4 minus 1 is 3, and 3 multiplied by d, that will give us 3d. So to solve for d, we need to transpose positive 9 to the other side. So to transpose that, we will have here positive 33, and if we transpose positive, this will change sign. It will become negative, so this will be minus 9 equals to positive 3d. So we have here 33 minus 9, this will give us 24, positive 24 equals to 3d. So we can rearrange this. We can write this as 3d equals to, okay, 3d equals to 24. Now to find for d, we need to cancel out 3. So to cancel out 3, we will divide both sides of the equation by 3. This will be 24 divided by 3. So 3 divided by 3, we can cancel this out. This is equal to 1. So 1 multiplied by d, this will give us positive d. And 24 divided by 3 is positive 8. We now have the value for d. We will just find for a sub 2 and a sub 3. So a sub 2 here, a sub 2, this will be equal to a sub 1 plus n minus 1 multiplied by d. Okay, so our a sub 2 will now be equal to our a sub 1 is positive 9 plus our n here, since this is 2, our n will be 2 minus 1 multiplied by d, which is positive 8. So our a sub 2 now will be equal to 9 plus 2 minus 1 is 1 multiplied by 8, that is 8. So as you can see, our a sub 2 is just the sum of a sub 1 and our d. So a sub 2 will be equal to positive 17. Okay, so this is positive 17. Now, let us find for a sub 3. Okay. A sub 3 will be just the sum of a sub 2 and d. So this will be a sub 3. This is just the sum of a sub 2 plus d. Okay. So the value for a sub 3 here will be equal to, our a sub 2 is 17 plus d, which is 8. So our a sub 3 will be positive 25. So our arithmetic means now, they are positive 17 and positive 25, and they are our final answers. Arithmetic means of an arithmetic sequence. Our given, we have positive 2 over 3, and we have arithmetic means composed of 3 missing terms. Okay, and then our last term is positive 2. So 2 over 3 here is our a sub 1. This is our a sub 2, a sub 3, a sub 4, and a sub 5. Now, to find for a sub 2 up to a sub 4, we are going to use the formula a sub n is equal to a sub 1 plus n minus 1 multiplied by d. So first, we need to find for the value of d, or the common difference. Okay, so we are going to use 2 or a sub 5. So our a sub 5 here, the value is positive 2. Okay, again, a sub 5 is positive 2, so this will be positive 2. Our a sub 1 is 2 over 3 plus our n, since this is the fifth term, our n will be 5 minus 1 multiplied by d. So 2 is equal to 2 over 3 plus 5 minus 1 is 4. So 4 multiplied by d, we will have here 4d. So to find for the value of d, we need to transpose positive 2/3 to the other side. So transposing, we will have positive 2. If we transpose positive to the other side, it will change sign. This will become negative or minus 2/3 and equals to 4d. Okay, so we have here 2 minus 2/3. So let's compute. 2 minus 2/3, this will give us 1 and 1/3. So we will have here 1 and 1/3 equals to 4d. Okay, so we can compute this as improper fraction. So we will multiply 3 multiplied by 1, that is 3, and 3 plus 1 is 4. So this will become 4 over 3 equals to 4d. So we can rearrange this. 4d will be equal to 4 over 3. And to find for d, we need to divide both sides of the equation by 4. Okay, so 4 divided by 4, we can cancel this out. This is equal to 1. So 1 multiplied by d, this will be equal to d. And we will have here 4/3 divided by 4. Okay, let's compute that. 4/3 divided by 4, that will give us 1/3. So 1 over 3. So our d is 1 over 3. It will now be easier for us to solve a sub 2 up to a sub 4. Let us now solve for a sub 4. So a sub 4, or rather a sub 2. A sub 2, this will just be a sub 1 plus d. So we will have here a sub 1 plus d. And our a sub 1, so our a sub 1 is 2/3. So 2/3 plus 1/3, this will give us 3 over 3, or this is equal to 1. So our a sub 2 is positive 1. And then we are now going to solve for a sub 3. So our a sub 3, okay, our a sub 3, this will just be equal to, since we already have a sub 2, this will be a sub 2 plus d. Okay, so the value here of a sub 3, this will be, our a sub 2 is positive 1 plus our d, which is 1 over 3. So this is 1 and 1/3. 1 and 1/3, or in improper fraction, this will be 3 times 1 is 3 plus 1, that is 4 over 3. So again, our a sub 3 here will be 4 over 3. 4 over 3. And let us find for our a sub 4. Okay, so for a sub 4, this will be equal to a sub 3 plus d. And our a sub 4 now will be a sub 4, this will be, our a sub 3 is 4 over 3. So 4 over 3 plus 1 over 3. So this will give us 5 over 3. So we have here the complete missing terms. Our a sub 4 will be 5 over 3. So therefore, our missing arithmetic means are positive 1, positive 4 over 3, and positive 5 over 3. They are our final answers. Arithmetic means of an arithmetic sequence. Our next problem, we have positive 1/2, and we have arithmetic means of 3 terms, 3 missing terms, 1, 2, and 3. And then our last term is 5 over 2. So we are going to find for the second, the third, and the fourth terms. Okay, let's call our first term as a sub 1. This will be a sub 2, a sub 3, a sub 4, and a sub 5. To solve for the a sub 2 up to a sub 4, we need first to find for d, or the common difference. And to find for d, we need to use this equation. A sub n is equal to a sub 1 plus n minus 1 multiplied by d. So for a sub n here, we are going to use a sub 5. So a sub 5, our value is 5 over 2. This will be equal to a sub 1. Our a sub 1 is 1 over 2 plus n. Our n here, since this is the fifth term, our n will be 5. So 5 minus 1 multiplied by d. So we have here 5 over 2 equals to 1/2 plus 5 minus 1 is 4. 4 times d, that will be 4d. So to find for 4d, or to find 4d, first we need to transpose positive 1/2 to the other side. So transposing, we will have 5/2. If we transpose positive, this will become negative. It will change sign, so this will become minus 1/2 equals to 4d. So 5/2 minus 1/2, this will be equal to 4/2, or 4/2 will be equal to 2. Okay, so this is equal to 4d. Again, 4 divided by 2 is 2, equals to 4d. So we can rearrange this. 4d equals to 2. Now to find 4d, we need to cancel out 4. So to cancel out 4, divide both sides of the equation by 4. 4 divided by 4, that is equal to 1. So we can cancel this out. This is equal to 1. So our d here will be equal to 2/4. We can still simplify this as 1/2. So our d is 1/2. So to find for a sub 2, we will just add our d, which is 1/2, to our a sub 1. So a sub 2 here will be equal to a sub 1 plus d. Okay. A sub 2 now will be equal to 1/2, which is our a sub 1, plus 1/2, which is our d. So 1/2 plus 1/2 is 1. Our d, or our a sub 2, is 1. And then for our a sub 3, okay, let's put it here. Our a sub 3 now, this will be equal to, since we now have the value for a sub 2, we are just going to add a sub 2 and the value of d. So our a sub 3 here will be, our a sub 2 is positive 1 plus our d, which is 1/2. So this will be 1 and 1/2. 1 and 1/2, or for to make this as an improper fraction, this will be 2 multiplied by 1, that is equal to 2, plus 1, that is 3. So this is 3/2. Our a sub 3 now will be 3/2, so 3/2. And let's find for a sub 4. Our a sub 4 now, we will just add a sub 3 and d. So for a sub 4, this will just be a sub 3 plus d. And since we have the value for a sub 3 now, our a sub 4 will be 3/2 plus 1/2. So this will be equal to 4/2, and 4 divided by 2 is positive 2. So our a sub 4 here is positive 2. So our missing terms, or our arithmetic means now, are 1, 3/2, and positive 2. They are our final answers.